In this video, we'll dive into the different feast service components supported by the operator and how one can customize data source configurations to suit their needs. As we progress, it's important to remember the Feature Store CR is the single source of truth for your feature store deployment when using the operator. So any feature store related configurations, for example, the feature store YAML file, will need to be modified and tweaked through the feature store CR itself. And in this video, we'll start to show you how you can do some of that. So let's take a look at where we left off in the last video. We've got our existing feature store CR deployed. Very little set in the spec, only the feature store project, which is the one required field. So let's get out of this guy and let's look at the existing feature store YAML to remind ourselves. This is a very basic and standard default feature store YAML file. So how do we tweak this if we wanted to? Well, for starters, let's start diving into the feast spec to see what fields are available. Specifically into the feast.spec.services. kubectl explain is a great way to dive into your custom resource definition and see what configurations are available. So let's look at feast.spec.services. In this video, we're mostly going to be focusing on these three core feast service components: registry, online store, and offline store. So to kind of kick things off, let's edit our existing feature store CR. Containers are ephemeral by default. So our current feature store deployment is ephemeral. If the pod or container crashes or the cluster is restarted, we lose our data. We may want to add persistence to our feature store. So let's look at how we could do that. In the spec, we are going to override what's currently configured for services. If we look in the status, right, the status applied, the current service configuration, which is an online store running the remote feature server, and we're using file persistence. We're going to continue to use file persistence for all of our service components, but we're going to use PVCs for both the online store and the registry. And we do that by specifying services, online store persistence, file-based persistence. We want a PVC and we want the operator to create one for us. And we want to mount it at /online. Similarly, registry is the same. We want the operator to create a PVC for us, but the mount point is /registry. One slight difference in registry, we're going to change the registry database file name to demo-registry. For the offline store, we're also doing file-based persistence, but we want, instead of the default Dask data store type, we want a DuckDB. Right, let's save that. Let the operator reconcile that. So let's immediately go check our cluster PVCs. We can see some very new 6-second-old PVCs have been created and bound for online and registry. That's good. It's important to note that the only way you can do something like this where the operator is creating PVCs for you is if you have functioning storage classes available in your cluster. We have two different types. You also, if you just want the operator to create one on the fly without specifying the type, like we did, you need to have a working default set. So just know that. Some other things we could have done instead of just issuing a create, we could have customized our create. We could have specified an access mode instead of just using the default. We could have did read write many. But you know, the storage class needs to support read write many. Not all do. We also could have specified the storage class name. We could have said GP2 instead. We could have told it to create a larger persistent volume than the one that we've created. All right, so let's dive into the PVC a little bit more. We also could have referenced an existing persistent volume. Maybe we didn't want the cluster to create one for us. Maybe we already had one. You can do that as well. All right, so let's look at our reconciled CR. And we can see immediately in the spec, the services look different. It's everything that we've set. And in the status as well, our services look a lot different. And some additional defaults have been applied, things that we didn't specify. Let's check on the health of our feature store. It looks like it's up and ready. Let's see how our feature store YAML has changed. Well, for one thing, we see the offline store has changed to DuckDB, and we're using our persistent volumes. So yeah, everything's looking good. You can actually even get into the pod and see that we have our mounted in volumes. But what if instead of file-based persistence, we wanted to use data store persistence, maybe an external database? Let's go ahead and do a quick demonstration of that. We'll create a Postgres SQL database in the cluster, a Redis backend as well. Let's check the pods and make sure that they're up and running. Good. Our data sources are up. And now we'll create a new feature store CR. That utilizes those data store backends. Let's look at what we just created. The most important part when creating a feature store that uses a data store backend is to have a corresponding secret that houses the connection information. And this connection information should match the Feast data store configuration for that particular data store type. I'll add links in the video description that you can use as reference for these different data store types. Within our feature store itself, we can see we're referencing the above secret, and we're telling it the type of data store that we would like. For online store, we want to use the Redis backend, and for the registry, we want to use the SQL backend. Offline store is the same. We're still using DuckDB. This server configuration here, we'll dive into all of that in a later video. Okay, let's see how our feature store YAML has changed. So in the new pod, in the new feature store, we can see our online store and registry are indeed using the newly running databases. Just so you can see the wide variety of data store types that are available for the online store, for example, but also offline and registry have a variety of data store types that are available. You can see that here. And again, I'll add links in not only to the different database types, but also to a quick operator quick start that mimics what you just saw. Thanks.